Welcome to the first lesson of the Integer Properties module. Now, in a nutshell, the topic of integer properties is largely related to how the composition of an integer affects its characteristics and the way it behaves. One of the central themes of integer properties is divisibility. If x and y are integers, then we say that x is divisible by y if there is no remainder when x is divided by y. For example, 30 is divisible by 5 since 30 divided by 5 gives us a quotient of 6 with no remainder. Similarly, 12 is divisible by 3 since 12 divided by 3 is equal to 4 with no remainder. Conversely, 8 is not divisible by 5 since 8 divided by 5 is equal to 1 with remainder 3. Now, another way to define divisibility is to say that if x and y are integers, then x is divisible by y if there exists some integer k such that x is equal to k times y. For example, 16 is divisible by 2 since 16 can be expressed as 8 times 2, where 8 is an integer. Similarly, 18 is divisible by negative 3 since 18 can be expressed as negative 6 times negative 3, where negative 6 is an integer. Now, as an aside, it's important to note that although the concept of divisibility can be applied to all integers, we typically restrict divisibility questions to positive integers. Okay, moving along, one last example here. 40 is not divisible by 14 since there exists no integer k such that 40 is equal to 14 times k. All right, now let's examine some more definitions. If x is divisible by y, then we can say that y is a divisor of x. Or if x is divisible by y, we can say that y is a factor of x. The terms divisor and factor mean the same thing, so we'll use these two terms interchangeably. So we can say that 4 is a divisor of 8, or we can say that negative 10 is a factor of 40. Now, although negative 10 is indeed a factor of 40, you'll see that on the test, questions typically focus on positive divisors. Okay, one last example here. 15 is not a divisor of 20. All right, let's practice our knowledge of divisors. What are the positive divisors of 12? Well, these are the positive divisors of 12 since they all divide into 12 without leaving a remainder. You'll notice here that the positive divisors of 12 include 1 and 12. As you might imagine, every integer n will have 1 and n as positive divisors. Okay, moving along, the positive divisors of 9 are 1, 3, and 9. The next one's for you. What are the positive divisors of 60? Well, let's list them. Now, a useful way to avoid missing divisors is to list them in pairs. By pairs, I mean two integers that have a product of 60. So we'll begin with 1 and work our way up to 60. Since 1 times 60 equals 60, we know that 60 is another divisor. Working our way up, we should recognize that 2 is a divisor of 60. And since 30 combines with 2 to get a product of 60, we know that 30 is another divisor. The next divisor is 3, and it pairs with 20 to get a product of 60. Next we have 4 and its pair of 15. Then there's 5 and its pair 12. Now, as you can see, each number and its pair are getting closer and closer to one another. Once they meet, we'll know that we've found all of the divisors. Moving along, the next divisor of 60 is 6, and its pair is 10. At this point, we can see that there are still some numbers remaining between 6 and 10 that we have not checked. So let's check them. 7 is not a divisor of 60, and neither are 8 and 9. So our list is complete, and these are all of the positive divisors of 60. Okay, another important concept has to do with multiples. If x is divisible by y, then x is a multiple of y. For example, since 14 is divisible by 7, we can also say that 14 is a multiple of 7. Similarly, since negative 36 is divisible by 3, we can say that negative 36 is a multiple of 3. To expand on this, we can say that the multiples of 10 are as follows. Similarly, we can say that the multiples of 6 are shown here. Now, although these multiples include negative values as well as 0, you'll find that the test typically focuses on positive multiples. So far, we've seen several different ways to express the concept of divisibility. You'll soon find that your ability to solve integer properties questions will depend on your ability to recognize how various statements are all equivalent. For example, if x and y are integers, saying that x is divisible by y is exactly the same as saying when x is divided by y, the remainder is 0. Another way to say this is y is a divisor of x. Or we can say that y is a factor of x. Or we can say that x is equal to ky for some integer k. Or we can say that x is a multiple of y. All of these statements convey the exact same idea. So be sure to know all of the various ways to express the idea that one number is divisible by another number. Later in this module, we'll add even more statements to this list. In a previous lesson, we found the divisors of some small numbers. Now, when the numbers are small, it's easy to find their divisors. For example, we can see that 3 is a divisor of 12, 5 is a divisor of 35, and 6 is a divisor of 42 just by looking at the numbers. But what about larger numbers? For example, is 3 a divisor of this number? In other words, is 20,012,441 divisible by 3? Well, it's hard to tell. We could divide 3 into this number to find out if there is a remainder, but this would take too long. A faster approach is to apply some useful divisibility rules, which we'll learn in this lesson. We'll begin with the divisibility rule for 2. Now, if a number is divisible by 2, then the units digit of that number must be 0, 2, 4, 6, or 8. So, for example, 2 is a divisor of these numbers since the units digit of each number is 0, 2, 4, 6, or 8. Conversely, these numbers are not divisible by 2 since the units digit in each of them is not 0, 2, 4, 6, or 8. Okay, now let's examine the divisibility rule for 3. This one is a little trickier. To determine whether a number is divisible by 3, we must find the sum of its digits. If the sum of its digits is divisible by 3, then the number itself is divisible by 3. For example, 3 is a divisor of 10,023, because if we add all of the digits, we get a sum of 6. Since 6 is divisible by 3, we know that 10,023 is divisible by 3. Similarly, this number is divisible by 3. When we add its digits, we get a sum of 21, and since 21 is divisible by 3, we know that 708,042 is divisible by 3. Finally, 2,817 is divisible by 3, since the sum of its digits is 18, and 18 is divisible by 3. Conversely, 23,401 is not divisible by 3, since the sum of its digits is 10, and 10 is not divisible by 3. Similarly, this number is not divisible by 3, since the sum of its digits is 25, and 25 is not divisible by 3. To determine whether a number is divisible by 4, just look at the number that is created by the last 2 digits. If that number is divisible by 4, then the entire number is divisible by 4. So, for example, 4 is a divisor of 60,012 because the number created by the last 2 digits is 12, and since 12 is divisible by 4, we know that 60,012 is divisible by 4. Similarly, this number is divisible by 4 because the number created by the last 2 digits is 36, and 36 is divisible by 4. Finally, this number is divisible by 4 because the number created by the last 2 digits is 0, and 0 is divisible by 4. Conversely, 35,014 is not divisible by 4. Here, the number created by the last 2 digits is 14, and 14 is not divisible by 4. Similarly, this number is not divisible by 4. since the number created by the last two digits is 73, and 73 is not divisible by 4. Next we have the divisibility rule for 5. This one is very straightforward. A number is divisible by 5 if the units digit is either 0 or 5. So 5 is a divisor of these numbers since the units digit of each number is either 0 or 5. Next we have the divisibility rule for 6. If a number is divisible by 6, then that number must be divisible by 2 and by 3. For example, 6 is a divisor of 10,032. We know this because the last digit of this number tells us that the number is divisible by 2, and we also know that this number is divisible by 3 since the sum of its digits is 6, and 6 is divisible by 3. So since 10,032 is divisible by 2 and by 3, we know that it must be divisible by 6. Similarly, this number is divisible by 6. Its last digit tells us that the number is divisible by 2, and since the sum of its digits is 21, we know that the number must be divisible by 3, since 21 is divisible by 3. Conversely, 6 is not a divisor of 77,032. Although the number is divisible by 2, it is not divisible by 3. We know that it is not divisible by 3 because the sum of its digits is 19, and 19 is not divisible by 3. Now there are divisibility rules for 7 and 8 as well as for other numbers, but you will not need them for the GRE. Next we have 9. The divisibility rule for 9 is similar to the divisibility rule for 3. If a number is divisible by 9, then the sum of its digits must be divisible by 9. So this number is divisible by 9. The sum of its digits is 18, and since 18 is divisible by 9, we know that 761,022 is divisible by 9. Similarly, this number is divisible by 9. The sum of its digits is 9, and 9 is divisible by 9. This number is also divisible by 9 since the sum of its digits is 27, and 27 is divisible by 9. Conversely, 23,401 is not divisible by 9 since the sum of its digits is 10, and 10 is not divisible by 9. Finally, we have the divisibility rule for 10. This one is the easiest. A number is divisible by 10 if the units digit of that number is 0. So 10 is a divisor of these numbers since the units digit of each number is 0. So these are the divisibility rules that you need to know for the GRE. Be sure to memorize them since they often come in handy.